Alrighty, so this is going to be day one. I have the test scheduled for you guys to take it tomorrow. So tomorrow I will go over more questions from the test review. So if I don't get your question today, it might be in tomorrow's recording. So wait to take your test if you want. You could take it whenever you want, but if you want to wait to take your test till after tomorrow's lesson, just so you have things fresh or any last minute questions, feel free to do so. When you take your test, I recommend you have your Desmos handy, a unit circle handy, your formula sheet handy. You might need a calculator, or if you just want to use the Desmos directly, just depends on comfort. If you want to use like a regular calculator like this, totally up to you. So if you want a calculator handy or just using the Desmos as a calculator. Formulas are going to be really important though. So let's go ahead and let's get started with it. So you're going to see some type of problems like this where we worked with the proofs. And so it's asking you what are the steps. So when I look here, I go, okay, well, they used the property of addition. They broke it apart into two pieces. So the next question goes then, okay, well, what would they do after that? Well, they broke it into addition. So that makes me think then if they broke it my x plus x and they wrote it like that, that makes me think that maybe I want to use my sum identity because this is the sum. And so I'm thinking sum identity, and I see sum identity over here, which makes sense, right? I see two sum identities. So I need to figure out, well, which one of these is it going to be? Because it is going to be the sum identity. That's why I wrote it as an x plus x. So I go to my wonderful formula sheet, and I look at my sum identities. And so when I look at it, I realize my sum and difference. So notice how we have it written like this, depends on how you guys have it on your paper. So it is going to be the sum. So I'm going to be using the top sign. So it's a plus. I'm going to use the top sign here, the top sign here. So what that tells me is that I could go ahead and write this as, so I'm going to just write it down here, that my tangent, oops, just because there's space in there. So I'm just going to write it out down here, x plus x is going to be, according to my tangent sum identity, it's going to be tangent of x plus tangent of x. Because they're the same, that's okay, all over 1 minus tangent of x, tangent of x. So again, looking at my formula sheet, we say we're using the top sign here because it's an addition. So the top sign and that top sign, so it's a minus here. So that's the difference between the two of these signs. So the correct one is going to be this one right here. What's kind of nice about these is that you do have your you do have the answers, so you can kind of see like this isn't matched with the double angle formula for tangent, so you could kind of cross those off. So that kind of helps eliminate. And then if they have the two options, then you need to figure out, well, what's the difference? What am I looking for? All right, my next one. Couple different ways to go about this. So you can always, it's multiple choice, you can always work backwards. So it's saying which of these are true. So between 0 and 360, which of these are true? So you have the values where x, your options given in your answers is that you have x can equal 0 degrees, 90 degrees, 180 degrees, and 270 degrees. These are the options of your given answer keys. So you can work backwards and you can plug into a calculator. So I could plug in 0 for these values. I could plug in my 90, and am I getting it, when I plug it in, am I getting it equal to 0? So that's kind of one way to go about it. That's a strategy, a test taking strategy where you use the test to help you. So yeah, these are your answers for x. Can I plug in those values for x and see if it's true? If I plug it in and it can't equal 180, then I already know then that it's not going to be either one of these two. So you can use that idea and work that way. Okay, well, what if I don't want to go that way? How are they actually, because that's not how they want you to do it. That's just a test taking strategy. You can use that for SAT testing, for whatever kind of test you're given, that's multiple choice. you can always look at the answers and then use them to help you. So how do they want us to solve it? Well, if I look at this piece, this is going to be a difference of tangent. So I would use that difference formula for tangent. And what that's going to tell me is that first piece right there is that tangent of x minus 180 degrees is going to be tangent of x. And so if I'm looking here, if it's a minus, then it's going to be a minus and a plus here. So you guys can see where I'm getting that from. It's a difference formula, so it's going to be tangent of x minus tangent of 180 degrees all over 1 plus tangent of x tangent of 180. And then it's going to be minus, and if I look over here, this is a difference of signs. It's a minus in between. So I want to go ahead and I want to use my difference of sign formula. So if I'm looking at difference of sign, it's a minus. So that means it's going to be a minus for these pieces here. So I'm using my difference of sign. So this is telling me that I'm going to have, now be careful because it's minus this whole quantity. It's minus this whole piece. So I'm going to do a bracket so it separates it. And it's going to be my sine of x, cosine of 180 degrees, and it's going to be minus cosine of x, sine of 180 degrees. Oh man, this looks like a mess. Like, where do I even go for this to solve for x? Well, let's try to simplify everything that we can simplify. What do I mean by simplify? Well, if it has these degree values with it, I can find what they are in my unit circle. So I need to figure out what is tangent of 180 degrees. On my unit circle, 180 degrees, my tangent is going to be my y over my x. So it's going to be 0 over -1, which is just 0. I can solve for cosine of 180. Cosine of 180 is going to be a -1, and I could solve for the sine of 180. Those are things that I can simplify. Sine of 180 is 0. So I could plug in all these values. So I'm going to kind of clean this up. And so this is what it's going to look like. I know tangent of 180 is just going to be 0. So this is going to be 0. This cosine of 180 is going to be a -1. The sine of 180 is going to be 0. So let's clean everything up. I end up with tangent of x minus 0 is just going to be tangent of x. This is going to be tangent of x times that 0. So it's really 1 plus 0. This whole thing would just 0 out. So it's really tangent over 1, which is just tangent. I don't even need to write that tangent over 1, right? So this becomes a negative sine of x. So it's minus a negative sine of x. This whole thing, since this is 0, this whole thing becomes 0. So I don't even need to have that piece. It's minus 0 there. And this whole thing is going to be equal to my 0. A negative and a negative makes this a positive. So I have tangent of x plus sine of x is equal to 0. I could choose to plug values into the calculator here. Or the other way to go about this is I could go ahead and get a common denominator and solve it out that way. It's going to be more work. So I kind of would recommend just kind of taking it from here and plugging in your values, but these are going to be options up to you. So I could plug in my 0. I can go ahead and write this as a common denominator, but that's really going to add a lot more work for you guys. So I would kind of take it from here and plug it in, especially because here, this could throw you guys in for when you plug in these values. These are values that you can work with easier on your unit circle. And remember, all of these are going to be your 0 and 1 combination. So they set it up for it to be easy for you guys to do that, because if it was something like your pi over 6 values, that would not be easy to solve for. So they set it up purposely like that. So this is where they want you to go. You can go ahead and plug into your calculator from here and solve it. Or again, some of you guys can mental math this, knowing what these values are on what's going to give you 0. So the 1's 1, then 1 has to be -1 to make it 0. So if tangent's going to be a value of 1 or 0, then sine has to be 0. That's the only way you're going to get 0. If tangent can't be a -1 there, because you're going to only be on these values. Tangent would only be a value of 1 or -1 if you had this values here. So they kind of have you just kind of use your knowledge on the unit circle to fill in the rest. Don't try to solve it beyond that, or you guys are going to go in circles. So, questions on that? All right. So next one, word problem. We talked about these. Usually it has something to do, does this have to do with the pendulum? Oh yeah. So the motion of a weight that hangs from a spring is represented by the equation. So here's our equation. It models the weight's height. So H in inches above and below the rest position. So here at 0 on my x-axis, that's going to be our rest position. That's the rest position. So it's either going to go up and down below it. And so this is going to be my height. My y-axis is my height. It's going up and down below it. And it's going to be in inches. So it says time is going to be in t seconds. So this is going to be my time in seconds. So again, this is my rest position is along my x-axis. It's going to be along this axis. So what is this going to look like? It's saying when, here's what we're looking for. When is the object, when will the object be 4 inches below the rest position? So rest position is going to be your x-axis. So we want 4 inches below. So we want it along here. So we want to see, well, when is that going to be, when is that spring, the weight on the spring going to be down here at below 4 inches from my rest position? So how do I look at that? Well, I would go ahead and I would plug this into my Desmos. I would go ahead and I would use Desmos. I would plug it into my calculator. The other way you could do this, just so you know, they want your y to be 4. So, your y-axis, which is your h. So you could plug in 4 here and solve for that t, but that takes a lot of work and it's probably not something that you guys want to do, especially when you're working with that sine value. So I would highly recommend plugging into your calculator. Let me go ahead and switch my share screen, new share, and let's look at it on the calculator, because I know this was one of the problems that some of you guys had a tough time with. So let me go ahead and let's go ahead and pull it up. Slowly. Oh, that's not what I want. I just want. Okay. So I want y is equal to -5 sine of, it's going to be 3 pi oh 3 pi divided by, so make sure you're getting it in the calculator correctly. Now remember, your x is going to be over here, not with the 4. Be careful because it changes the graph. If I put the x down here, it's going to change your graph drastically. Look at that versus it over here. So you need to make sure that you're seeing it after it. And let's go ahead and end our parenthesis there. All right, so again, we're looking for when does this graph, so it has to be at a time of 0. So we can't be looking at anything that's going to be to the left here. So we could even move this over and see like, okay, we don't want anything over there because you can't have a negative time. Can't go back in time. So we're seeing, okay, starting from 0, when does it hit the value of -4? And so I can look right here and I can see that that value of -4 is going to be at 0.398-ish. So somewhere, depending on where you move it. So you got a 0.4 there. So you just kind of get to it as close as you can, whatever you think is the closest, because only one answer is going to match. So I'm looks pretty close right here, and I got a 0.394. So 0.394 is what I had for that X value. Your X-axis is your time. So that 0.394. So when I saw my graph, it came down and it looked like this point right here was at my 0.394 when this was about my 4, I don't know, it was 4 something negative. So my answer would be right here. So the biggest thing for this problem is that it was below. So you were looking for the negative value. If it said above, you'd be looking for the positive value. So little things like that, like understanding your ref's position, and then knowing above would be positive, below is going to be negative. Done. That's it. So don't overthink it. My next one. Okay, these type of problems are a struggle. I cannot tell you how to do them exactly because they're all done differently. Like you could get the same answer and it doesn't look anything like it. Bernice had sent me a question and the answers were totally different. Do I have it? I think it was on your guys' review. And so it was it from the review, Bernice, that you had sent that? Okay, and so let me show you, I have it somewhere. Where did I work it out? Do I not have it? Okay, so one of the problems was this from the review. And so I would have done it as a sum as well. And when you solve this problem as a sum, you get this answer, which is perfect. But they did not give you any answers that look like that. The answer that they gave you was actually this answer, but you didn't solve it that way, so you didn't get that answer. So you kind of had to put in the calculator to see, well, which one does it match of the answer choices they gave me. That can happen. I think they used the half angle formula for this, and not the sum. So you might solve it using differences and they solve it using sum. So your answers are equivalent, but they might look different. Or maybe you did a double angle and they did a difference. Like there are more than one way to get the same answer. So just because you did it one way and you're not getting the right answer doesn't mean you did it wrong. They just may have it in a different format, which I wish I could guide you guys better on like what to do about that. But there's so many different problems. Like I can't say, hey, this problem is going to be like that because the bank is too large for me to go through and how they solved it. So just be aware of it. So with this problem, I naturally default to the sum and differences if I could do sum and differences. And this one's a little bit of a tough one because A, it's tangent, which you guys don't like, and B, it's working in radians, where using sum difference, if we're in degrees, it's a lot easier. We like that a lot better. So let me go ahead and show you what I would do here. If I want to find two values that add to that, I go ahead and I need two values that add to 19/12. Well, what I do is I know it's going to be over 12. I've got to have a common denominator. So when I set this up, I need to have my two numerators add to 19. What are two numerator values that add to 19? And I don't always get it the first time, but I know if I look here at 15 pi and 4 pi. So when I pick the values, I need to simplify anything that can be simplified. So this is the same thing, 15 pi over 12 simplifies to 5 pi over 4. 4 pi over 12 simplifies to pi over 3. Now my question is, are these values, these simplified values, values that are on the unit circle? Are they going to be values on the unit circle? If they are, then I could go ahead and use this. So when I look here, I go 5 pi over 4 on my unit circle, check. And then of course, hopefully you guys know your pi over 3 is on the unit circle. So these are on my unit circle. That's exactly what I want. So I can rewrite then tangent of 19 pi over 12 is the same thing as tangent of 5 pi over 4 plus pi over 3. And then I could go ahead and use my sum identity. So that tells me then that I have tangent of 5 pi over 4 plus tangent of pi over 3 divided by 1 minus tangent of 5 pi over 4 times tangent of pi over 3. So I need to figure out what is tangent of 5 pi over 4. I just like to do my work just here off to the side. Tangent of 5 pi over 4. I go to my unit circle. The y value is the square root of 2 over 2. The x value is a negative square root of 2 over 2. A negative and negative makes it a positive. Square root of 2 over 2 divided by itself is just going to be a value of 1. Tangent of pi over 3 is equal to my y value of pi over 3 is square root of 2 over 2 divided by a 1/2. They have the same denominator, so I could cancel it off. So it's just going to be the square root of 3. I plug in my values. This is going to give me then 1 plus the square root of 3 all over 1 minus 1 times the square root of 3. So it's 1 plus the square root of 3 all over 1 minus the square root of 3. And I'm like, ooh, I'm so close, but I don't see my answer there. This isn't wrong. This could have been the answer they gave you. They didn't. That's okay. What they did was, if I look here, they don't have any denominators. So they rationalized it. So I'm going to multiply it by the conjugate then. Remember, that's how we get rid of our square root here. So I'm going to multiply it by 1 plus the square root of 3. So 1 plus the square root of 3. So again, we're getting rid of the conjugate. So this is going to give me then 1 times 1 is 1, plus it's going to give me a square root of 3 plus another square root of 3. So it's 2 square root of 3. Square root of 3 times square root of 3 is the square root of 9. Okay, good question. So it's the square root of 9. Square root of 9 is just 3. The conjugate is when you have the same term. So let me kind of review conjugate. Since this is a minus, the conjugate is with the plus in between. So whenever you want to get rid of a square root, you multiply by the conjugate. We also use the conjugate for imaginary numbers. So if I have 1 plus the square root of 2, the conjugate would be 1 minus the square root of 2. If I have 1 minus 3i, the conjugate would be 1 plus 3i. So the only thing that changes is the sign between the two. So when you do that, every time when you do that, you multiply the conjugate for your imaginaries or for your radicals, it gets rid of the radical or the imaginary number. So look what happens here. When I multiply these, I get my 1, I get a positive square root of 3, I get a negative square root of 3, and then a negative square root of 3 times the square root of 3 is going to be a negative 3. So these will always cancel out. So I end up with a real number in my denominator. So I end up with then 4 plus 2 square root of 3 all over negative 2 which can simplify. If these three terms have something in common, I can simplify. So -2 goes into 4, -2 times, and -2 goes into -2, -1 time, square root of 3. If you put that 1 there, it's not wrong, it's just not necessary. So your answer should have been this value right here. So again, this answer wasn't wrong. It could have been your answer choice. They didn't leave it like that. So I had to get rid of that radical. The other option is to put this in your calculator and put these in your calculators and match up your answers that way. I wish I had a better strategy for you guys. And our very last one, this is from way back in the beginning when we worked with our triangles. Law of sines, law of cosines. So it says, from where Kiana is standing, she must look up 50 feet to see the top of the building. If she backs up 50 feet, she will still look up at a 40-degree angle to see the top of the same building. Approximately how tall is the building? So what they want to know is this value right here. That's what they want to know. So how do I figure that out? Well, I have two different triangles here I could look at. I have a couple different things. So I can focus in on this triangle or this bigger triangle, actually, and I also have this little piece right here. So I have three different triangles technically. This little piece right here doesn't have anything, doesn't connect to that X. So I'm like, I don't even think I need that, do I? What do I want to do? How do I want to go about this? So I look here and I go, okay, well, I mean, if I can just use just this piece, I know it's a right angle, then that's what I'm going to do. But when I look here, all I know is two of the angles. I know a right angle. I mean, I guess I know all my angles. But remember, there was no AAA property. There was an SAS, SSA, but there was no, if I know all my angles, it doesn't help me figure out any of my sides. That doesn't help me. So I'm like, okay, well, if I know what this is, what this side is, or I know what this side measures, then I can use that to find this side. I don't know it. Okay, so I'm thinking, well, what do I know? What can I do? So I look at this triangle here, same idea. I don't know this. I know this little bit, but I don't know this whole thing to get to my X value. So same problem that I just outlined in the first one. But when I outlined this first one, I said, oh, if I could figure out this piece or this piece, then I can solve for that X. So I'm like, huh. Well, I did say something about this third triangle right here. And I do know an angle, and I do know a side. And although they didn't give it to me, do I know this angle right there? Yeah, because these two angles are supplementary. They add to 180. So if this is 50, then this has to be 103. So I know an angle, a side, and an angle, right? So can I use this information to help me find this side right here? And if I know this side, then I could find my X. Oh man, that's a lot going on, right? Okay, so let me go ahead and I'm going to label this triangle A, B, C. So my first goal is to figure out what is this side right here going to be? And that's actually going to be my little a, this is my little b, and my little c. And I labeled it just to help you guys give yourselves like a visual or when I use like reference. So for my triangle number 1, I want to solve for this side A. So I labeled it triangle A, B, C. I know my side A is, my angle A is 40. I know my angle B, well, I could figure out angle B has to be, if this is 130 plus 40 is 170, this has to be 10 degrees because it has to add to 180. And this is going to be 130 degrees. My side A, that's what we want. My side B is this side over here, I know is 50. And my side C, I don't know it either. The reason why I set it up like this is because do I need to use law of sines or law of cosines? Well, I see that I have a full set, which means I can use my law of sines. And I'm looking for this a, so I want to make sure I'm using my sine of a's as well. So I'm going to do a all over sine of 40 is equal to 50 all over sine of 10. So this was my b, my capital, just so you guys can kind of remember how it all went. So I'm going to cross multiply and I get a sine of 10 is equal to 50 sine of 40. Divide both sides by sine of 10. I plug this in my calculator. Make sure your calculator is in degrees. And when I do that, I get A is 185. So this is going to tell me that this side right here is 185 feet. I still haven't answered the actual question. But remember, I use law of sines and law of cosines when I don't have a right triangle. That's why I have to use that. But if I have a right triangle, why don't we just use SOHCAHTOA? So for this x value, for x, I'm going to focus in on this triangle. I'm going to call it triangle number 2. It's a right triangle. So I can use SOHCAHTOA. Sorry, kind of messy. So I can say that this is my focus angle, then this is my opposite, adjacent, and my hypotenuse. So I want my opposite side and I know my hypotenuse. I want my opposite, I know my hypotenuse, so I'm going to make sure that I use sine. And if it helps, you can always redraw the triangle right here so you can see that this is my 50 degrees, my adjacent. I'm looking for my opposite side, and my hypotenuse was 185 feet. So this tells me I have sine of 50 degrees is equal to my opposite over my hypotenuse. So it's 185. Multiply both sides by 185. They actually used 185.1. So I'm going to use 0.1 here. Otherwise, I think your answer is rounded off differently. You guys will get close to it. So times my 185.1 times my 185.1 cancels out. So my opposite side is sine is 185.1 times sine of 50. And I put this in my calculator. And I get the opposite side is approximately 141.8 feet. So this X, the height of the building, is 141.8. So kind of a lot of material, a lot of stuff going from way back that you guys are like, oh my goodness, we did that in this chapter. So make sure you, again, have all your notes and everything handy so you could go back and reference anything you guys need. I have more problems tomorrow. I would keep these problems with you as you're taking your review or doing your test so that you have problems to reference back as well. If you guys have all the resources at your fingertips to help you through your exams. If you have any questions, please message me. Otherwise, you guys have a fabulous day. Good luck working on the review. Let me know if you guys need anything. You're so welcome. You have a wonderful day. Bye, girls. You're welcome.